Okay, so this week we are going to start looking at some different things with graphing. And it's going to end up going with proportional relationships because starting tomorrow, we're going to look at how you can tell if something is proportional by graphing the points instead of just looking at the unit rates every time. That's another way that we can see if something's proportional. And this week and next week are going to be focused on graphing and proportional relationships. Today we're just going to get started on kind of an introduction to graphing. I'm sure some of you have done some things with them before, some of you might not have. Also, you're going to be doing basically the same lesson today in Mr. Harvey's class, but he focuses on the geometry, so plotting points and making shapes with them, finding the area. We look at completely different things, but kind of an introduction to graphing for both of us. I wish I could say we do it because great minds think alike, but that would be giving Mr. Harvey too much credit. We kind of planned this out on purpose because you get a view of graphing from me, you get a view of graphing from him. It's the same basic thing, but it's two different areas that you're looking at, and so hopefully by the end of today, you all are pros at graphing. So the coordinate plane is what a graph is called in math, and it forms a grid, so like you see at the bottom of your paper there, a grid, and the two kind of middle lines, they're really just number lines, that's all they are. One's horizontal and one's vertical. We call them an axis, and they intersect where they both equal 0. And so all of that has to do with some different things we'll talk about later. And to locate a point on a graph, we use what's called an ordered pair. That tells us what coordinates it goes at. And the big thing to remember is the x-coordinate comes first in an ordered pair. The y-coordinate comes second. So it's x comma y, and that's how you know where to find a point or where to graph a point on the coordinate plane. All right, so along with those two terms, we've got axis. An axis, that's the number lines that kind of make up the coordinate plane. They intersect where both of them are 0. The x-axis is horizontal, it's side to side. And the y-axis is vertical, it goes up and down. And they intersect where they both equal 0, which is what we call the origin, which is the last word down there. That's the point 0, 0. X is 0, y is 0. It's where those two x and y axis meet. And then the x and y axis, their intersections form 4 quadrants of this graph, of this coordinate plane. So there's some things we'll talk about that deal with the all 4 quadrants here in a second. Another thing about the origin, before we move on, anyone know what the word origin means? Just in general. We say it's the origin of something. The beginning. So the origin is kind of like the beginning of the graph. It's right in the middle, okay, because where everything meets. And every time that we're going to plot a point, we're going to count from the origin. So we start at 0, 0, and if we've got to go left 2 and up 3, we start from 0, 0 and go left and then up. And so the origin is kind of the start of when we graph points as well. So looking at the coordinate plane there on your paper, we're going to label it a little bit. Red. So the first thing is, let's label the origin. The origin is right there. So that's the origin. And that point is 0, 0. X is 0 and y is 0. So you see these two number lines, the x-axis, y-axis, they meet at the origin where both are 0. Also, like I just said, we've got the x-axis, which is right there, and the y-axis, which runs vertical. So one thing about the x and y axis, anytime a point is on the x-axis, the y-coordinate is 0. Because on the x-axis, you have not moved up or down any. Anytime you're on the y-axis, the x-coordinate is 0, because you haven't moved left or right any. And so that's one thing. If you see a 0 as a point, it's going to be on one of those axes. So let's also label our quadrants. So anybody know where quadrant 1 is at? Quadrant 1. Tell me up, down, left, right, basically. Taylor? Top right, yes. And we use Roman numerals to label the quadrant. So quadrant 1, we'll write it like that. And in quadrant 1, notice that your x points are all positive right here. And your y coordinates are also all positive. So the point is going to be positive and positive. So if both x and y coordinates are positive, you know you're in quadrant 1. You see the x-axis, all positive numbers, the y-axis, positive numbers as well. Okay, so which direction do we go to get to quadrant 2? Do we move to the left or do we move down? To the left, yes. So quadrant 2 is right here. We're kind of going counterclockwise, the opposite of a clock. The quadrant 2 is right here. So notice the x-coordinates in quadrant 2 are what? They're negative. But the y-coordinates are still positive. So x is negative, y is positive, you know you're in quadrant 2. So then quadrant 3 is going to be underneath quadrant 2. The x-coordinates are positive or negative?
Negative.
They're still negative. You see right here, quadrant 3, x is still negative. And now we are below the origin. So if we're below the origin, what do you think y is going to be?
Negative.
Negative as well. So if both x and y are negative, then you know you're in quadrant 3. And then quadrant 4 is the bottom right. X is what now? X is positive. You see all the x values are now positive, so x is positive, but since we're still below the origin, y is going to be negative. And so if you notice, what is the opposite of quadrant 1 as far as positives and negatives? Quadrant 3, right? So we're going this way across diagonally. They're both positive in quadrant 1, they're both negative in quadrant 3. And then quadrant 2 is opposite quadrant 4. The negative changed to positive, y is positive, now it's negative. Okay? A couple other things. Think about the coordinate plane and what we've just done. What other class, other than Mr. Harvey's class, uses kind of like a coordinate plane? Wanda?
Social studies?
Okay, social studies. So what are the x and y axis in social studies? You know what it's called? What's the thing that runs across the earth? It's really hot there. The equator. That's the x-axis, right? And remember what this is called? The y-axis, it runs up and down. The prime meridian, yes. So the equator, prime meridian. And then don't you have coordinates when you put stuff on a map? So I don't know if you all done it yet. Have you?
Teachers, pardon the interruption, but due to several forced absences right before fall break, we have several, particularly 8th grade students, that need to complete some makeup clear sight testing. So if I call your name at this time, would you please make sure that you bring a pencil and your materials and meet me, Mr. Grove, in computer lab 121. Following students again meet at lab 121. Amadou Abdul Kareem, Genesis Austin, Camden Bennett, Eris Blair, Caden Brinkman, Jackson Burns, Jamie Chan, Matthew Craig, Jeremiah Davis Moore, Delaney Dunderdale, Mackenzie Embry, Valerie Fernandez, Josh Fuentes, and Charlie Gibson. If those students would meet me in lab 121 at this time with a pencil. Thank you.
Have you all done the project where you find the coordinates of like the school or your house or something? Yeah. So those coordinates are like coordinates on a map. Or the coordinates on a map are like on a graph. You've got the x and y axis, the equator and prime meridian, and then from there you can see what the degrees or what the coordinates of a spot are. Another thing, if you look at a map of Indiana, maybe not so much Indianapolis, but go outside of Indianapolis, the roads in Indiana kind of look like this. And so the reason why it looks like a grid was so in the old days, before they had cell phones and could see where on a map where everything was, if you called 911 and said, I need an ambulance at my house, and you said, I'm on County Road 200 West, well, they knew, here's the courthouse, that's the center of town. So 200 West, you would be west 2 miles. And so they know I go 2 miles west of the courthouse, and that's where that road is at. 10th Street runs over here. 10th Street is exactly 1 mile north of the courthouse. So 20th Street would be 2 miles north. 30th Street is 3 miles north. And so that's actually exactly the miles, 10th, 20th, 30th is exactly 1, 2, 3 miles. And so if you live on 30th Street, that's 2 miles away from 10th Street. From 10 to 30, 10, 20, 30, you're 2 miles away. And so that's one way as well that certain cities keep track of how far the streets are away from each other. If we have time this week, we'll look at a video that New York City is the way the streets are. They're actually exactly certain distances away based off the numbers of the street. And so you see it a lot in maps using some type of coordinate plane, and it just helps know where everything is at. So kind of putting those together with other classes. So we're going to look at a few different examples on identifying different points today, and this will help us as we move into the rest of the stuff this week. So looking at these points on this graph, the question is, what are the coordinates of those following points? So you see where A is. We're going to write the coordinates of A. So first of all, what quadrant is A in? What quadrant? It's in quadrant 1. So you know that both the X and the Y points have to be positive, because X and Y are both positive there. Okay, so what we're going to do is we're going to start at the origin. Remember, origin is where we start or begin at. We're going to see how many spaces do I count to the right, and then we're going to count up. So to the right, on the x-axis, we go over 2 times. So 2 is the x-coordinate, and then y is up and down. So we have to go up, 1, 2, 3, 4, and so it'd be positive 2, positive 4. We go to the right 2, that's positive in the x direction. We go up 4, that's positive in the y direction. So 2, 4. Point B. Point B is in quadrant 2. We know that quadrant 2, the x-coordinates are negative, because we are going to think of a number line, to the left of 0 is always negative. So this is going to be negative 2, but we go up 1, and so up would be positive 1. So you're going to see, what is it left to right? What is it up and down? Left and right comes first, though. X-axis comes first. So point C. It's right there on the x-axis. So we're going to count how many times to the right do we need to get to C? 7? Do we go up or down any? Okay, so what should the y-coordinate be if we haven't gone up or down any? It's still at 0, yes. So if you're on the x-axis, the y-coordinate's going to be 0. Okay, point D. Point D is in quadrant 3. Quadrant 3 is the one where both x and y are negative. Because I'm going to the left, which is negative. I'm going down, which is negative. So count how many times you have to go to the left. Is it 7? And then I go down 4. So negative 7, negative 4. Okay, E. So notice E, I've gone to the right, so I'm positive in the x direction, but I've gone down, so y is going to be negative. So we're going to go over positive 5 and then negative 8. Positive 5, negative 8. And then F. Have I gone to the left or right any?
No.
So what should the x coordinate be?
0.
0. What should the y coordinate be? Negative 4, yes. I haven't gone to the left or right any, so x hasn't moved, but I've gone down 4, so it's going to be 0, negative 4. 0, negative 4. So if you're on the y-axis, the x-coordinate is going to be 0, because you haven't moved any on the x-axis. Okay, so any questions about picking what points we have? All right, so we're going to do the opposite now. They give us the points, and we're going to go and plot them on this graph. So when we plot them, make sure that you label as well what's A, B, C, D. So A is positive 4, positive 6. Always start at the origin. Always start at 0, 0. You're going to go 4 to the right because it's positive 4. And positive 6 means we go up 6. Plot a point right there and say that's A. Okay, when I go to plot point B, I'm going to start at the origin again. So I'm going to start back at 0, 0 once again. This time I'm going negative 3. The first is left or right. So negative in the x direction would be to the left. And then positive 2 means I'm going to go up 2. So negative 3 is left 3. Positive 2 is the y coordinate. I go up 2. C. 0, negative 1. Do I move anything on the x-axis? But what should I do? 1 where? Down 1, yes. So x hasn't moved any, but I'm going to go down 1 to get the C. Okay, D, both are negative. So both are negative, I know I'm going to end up in quadrant 3. So I'm going to go left 3. And then negative 7 is going to be down 7. And that is point D. Point E, 4, 0. So 4, 0, I'm going to go positive 4, which means I go 4 times to the right. Do I need to go up or down any? The y coordinate is 0. That means I haven't gone up or down. So point E just stays there on the x-axis. And then point F, negative 2, negative 5. I'm going to go left 2 and down 5. So the first number is x-axis, left or right. The second number is the y coordinate, up or down. So you're going left or right first, and then up or down after that. Any questions there about plotting those points? Okay, so the last set of questions you've got, it does not give you a graph. It just gives you points. And you need to tell me what quadrant are those points going to be in, 1, 2, 3, or 4. So I want you all to finish off and do this one. So look at those points where the coordinates are. Tell me what quadrant is it going to be located in. I would look at the coordinates, which ones are positive, which ones are negative, and use that to help you answer these. Okay, so point A, x is positive, y is negative. So what quadrant would that be? 1, 2, 3, or 4, AJ? It'd be quadrant 4, yes. X is positive, y is negative, quadrant 4. Okay, point B, x is negative, y is positive. Okay? It'd be quadrant 2. Yeah, you're going to go to the left and up, so quadrant 2. Okay, C, x is 0 and y is 1. Quadrant 1. Okay, but if I am looking at this, if x is 0 and y is 1, I'm right here. So where am I at? I'm on the y-axis. So couldn't it also be quadrant 2? Yeah. So what is it? Both or neither? If you are on the axis, x or y axis, just say it's on the y-axis because it's not in a quadrant. So that's kind of a trick question. That would just be the y-axis. So the x-axis and y-axis, they're not in a quadrant. They're just kind of by themselves because they separate everything. Okay, point D. Both x and y are negative. So what quadrant is that, Desmond? 3. Quadrant 3, good. Point E. Both are positive. So it would be quadrant 1. And then point F. X is 1, but y is 0. So where would that be at? It'd be the x-axis. Any quadrant or just the x-axis? Just the x-axis. Good. So if it's on the x or y-axis, we don't say it's in a quadrant because it's technically not. We just say it's on the axis. Alright, so no practice in the books, but I do have a paper